Let us evaluate the integral of secant to the power 5 of x. When dealing with an integral of secant and our exponent is an odd number, we must first factor out secant squared of x, making this the integral of secant cube of x multiplied by the factored out secant squared of x dx. And we can think of this as one part and this the other part. This is because what we're going to do next would be to integrate by parts. The formula once again for this would be the integral of u dv would be equal to u multiplied by v minus the integral of v multiplied by du. In our case, u here would be secant cube of x and dv would be secant squared of x dx. U here being this one. And the derivative of secant cube of x, this is chain rule because it has an exponent. Focus on the exponent first, bringing down the exponent which is 3 and copying this which is secant x, and the exponent here would be subtracted by 1, so this would be 3 secant squared of x. And multiply this by the inner part which is simply secant of x. The derivative of that would be secant of x tangent of x. And of course, don't forget the dx. Simplifying this, we would have the value of 3 secant cube because we have a secant of x there, and tangent of x dx. So this would be your final du value. Focus on dv now. dv right here is secant squared of x dx. Taking the integral of secant squared of x, it is actually equal to tangent of x. And now by that, based on the formula, we would have the value of something like this. U here is secant cube of x. V here would be equal to tangent of x minus the integral of v, which is tangent of x, multiplied by the value of du, which is this one. Let me just make some space here. Now that we have that, we can simplify this. You can see here that tangent of x would multiply against each other. But first, let's put the coefficient in here. So this would be 3 tangent squared of x multiplied by what's rest, which is secant cube of x dx. Actually, since what we have here is a coefficient, we can put it outside the integral. So like that. And now the next step here would be to simplify this integral. And that means transforming tangent squared of x according to its trigonometric identity. Note that tangent squared of x is equal to secant squared of x minus 1. And for that, we can simply replace this by its trigonometric identity. So this would be secant squared of x minus 1 multiplied by the rest. And the next step would be to distribute secant cube of x among the parentheses. So this would be secant squared of x multiplied by secant cube of x would be secant to the power 5 of x minus multiplying this, it is secant cube of x dx. the next step for here would be to split this integral into two parts. So splitting the first part, we would have 3 integral of secant to the power 5 of x of dx. And for our second part, you can see here, we have a negative sign and we have a negative sign here, which makes this plus, and copy the coefficient, which is 3 integral of secant cube of x dx. And the next step, you can see here that we have secant to the power 5 of x, which is actually the same as our problem right here. If you encounter a problem like this, it would be best to eliminate this instead of being in a loop. So what we're going to do here would be to equate this to each other, because this integral is basically the same as this. We had just modified it. Would be equal to this value right here. And now the next step would be to eliminate this from our side. So add both sides 3 integral of secant to the power 5 of x dx. By that, this would equal to 0. 1 plus 4 would 1 plus 3 would be 4. Would be 4 integral of secant to the power 5 of x dx. And copy the rest first here. And now the next step would be to eliminate the coefficient of 4. And now the next step would be to eliminate the coefficient of 4 in here, because what we only need is a singular integral of secant to the power 5 of x. And so what we're going to do here would be to divide all sides by 4. So this should be eliminated. Which makes this reverted back to the original problem. And for this, we can simply think of this as 1/4 multiplied by secant cube of x tangent of x, plus, since what we have here is 3 and 4, it would be 3/4 the integral of secant cube of x dx. The next step would be to simplify this again. What we have here is already simplified. This what is left, 3/4 the integral of secant to the power 3 of x dx. But in this case, I will just be putting the direct answer based from here, because now that we have reached this step, it is time now to simplify this. What we have here is already done, and what's left here would be the integral of secant cube of x dx. What I'm going to do in this video would be to just put the direct answer of the integral of secant cube of x. You can check out my previous video that I had made, because it is quite a long explanation on how to get the answer of this again. And so this would be like this. Or actually, I will not put that. I will just put the final answer. So this would be 1/4 multiplied by secant cube of x tangent of x plus 3/4 multiplied by the integral of secant cube of x dx, which is equal to 1/2 secant of x tangent of x plus 1/2 natural log of the absolute value of secant of x plus tangent of x. And of course, don't forget to add the constant of integration. And now, your final answer here would be to simplify this, which is equal to 1/4 secant cube of x tangent of x plus 3/4 multiplied by 1/2 would be 3/8 secant of x tangent of x plus 3/4 multiplied by 1/2 again would be equal to 3/8 the natural log of the absolute value of secant of x plus tan of x plus c. So 3/8